Stream API. Now, before we understand Stream API, first of all, it's a new concept. It came in 1.8, Java 1.8 basically, and it provides some amazing feature. The only thing is, why do we need those features? We'll understand that first. So what I will do is, first of all, I want to create a list of values. Okay, so let's create a list here, and I will say this is of type integer, and I will say nums. And of course, just to keep it simple, I'm going with the default names so that you don't have to focus much on the naming convention. I want you to focus on the concept. So we have the array list here, and in this array list, I want to have some values. We have nums dot, let's add some values. I would say add 4. In fact, you know what I want to do? Instead of adding values like this, there's another way using which you can add values in the list, which is there's a class called arrays, and arrays dot as list, and you can simply pass the values here instead of manually typing the values. Even this works. So as list is a method which gives you a list, and it belongs to a class called arrays. Okay. This is much simpler, right? Now, once you got this list, what if you want to print these values? Of course, I can say sout and I can say nums. And by doing this, we can simply print all the values, and you can see we got all the values. Now, what if I want to perform some operation on this? Okay, now what kind of operation I'm talking about? So let's say I want to double all these values. And in fact, I want to first apply the filter here. So let's say I don't want odd numbers. I only want to focus on even numbers. Example, we have 4 and then we have 2. Ignore this dot dot a, basically it represents an array. So we got this 4 and 2. I want to filter them. And whatever value you get after filtering, I want to double those values. So example, 4 and 2 becomes 8 and 4. And at the end, I want to reduce it. So I want to say, okay, 8 plus 4 is 12. So I want the output to be 12. The way you can do that, first of all, I want to apply the filter, right? So we can use a for loop, and we can go from the first value to last value. So I can say int n colon from nums. And once you get this value, I want to apply the filter. Because see, I don't want to add all the values. I want to add only the odd numbers, and that too after doubling it. I want to add even numbers basically. So we can check if my n mod 2 is equal to 0. That means that's an even number. If that's an even number, I will first of all double the value. So I will say n is equal to n into 2. So doubling done. And then once you have doubled it, I want to add it to a sum. Let's say I will create an int sum variable. The initial value is 0. And whatever doubling you get, you simply say sum is equal to sum plus n. Okay. So by doing this, what I'm doing is from all the values which we have here, let's say we have some more values. Let's say 6 as well. And let me add one more value here, which is 3. So you can see we have so many values, but I want to first of all filter only even numbers. Example, I want to fetch this 4, then this 2, then this 6. I want to double each value. So example, 4 becomes 8, 2 becomes 4, and 6 becomes 12. So this is 8 plus 4 is your 12. 12 plus 12 is 24. I want the output to be 24. And let's see, do we really get 24 here? Let me print the value for sum, compile and run. And you can see we got 24. Now this is one way of performing the operation on your list. Now sometimes you perform such an easy operation, and sometimes maybe you do something by using which the values, in fact the original values gets changed. So instead of doing those things, we got this amazing way of doing this calculation, which is called a Stream API. Now it was introduced in later version. Before this, people used to work with this way, but in Stream we got a different way of doing this. Okay. Now basically we got this new thing which is called Stream. So if I jump to Stream, which belongs to java.util.stream package, and if I click on Stream, you can say Stream is an interface, and it provides you multiple methods like we got filter. That makes sense, right? If you want to apply the filter on the stream or the collection, we can use filter. If you want to change a value, example, we have doubled the values, right? That can be done with the help of map. And we'll individually see these methods later. So if you go down, you have sorted. In fact, there is also a method called reduce. We are going to use that as well. Yeah, so there's reduce as well. Okay, we'll see that later. So basically, Stream provides a lot of methods to work with this. Now, how exactly to use Stream, that we'll see in the next video. But before that, I want to show you one thing. So let's say we were able to do this, right? At this point, I will just comment this section because we'll talk about that later. I want to do one more thing before we start with Stream, which is how do I print all these values? A simple printing. So we can use a normal for loop, right? The normal for loop works in this way. We can use int I is equal to 0 and int I less than, we have to get the nums dot length or size. Yeah. The method name is size, and then we have to say I plus plus. So we have basically we have to use normal for loop, and then we can print each value. I can say nums dot get, I can pass the index value. And if I clear this, compile and run, and you can see we got all the values here. Okay, this is one way. I can comment this section. The another way of doing this is using a normal for loop. I can say for int n is equal to num, and here I can simply print the value of num. Even this works, right? Now you tell me which is better, using a normal for loop or the enhanced for loop. See, normal for loop, what it does is it basically goes to the loop, or it basically goes to the list by saying, hey, I want to fetch the first element, I want to fetch the second element, right? On the other hand, if we talk about the enhanced for loop, it says the array itself will give you the value, and that value goes into n, right? Now again, this too looks good, but then we have a better way of doing it. So I can just comment this section. The better way is very simple. What you can do is you can say nums dot. Now we got a new method called for each method. Now using this for each, it will give you one value at a time. You can save that in n, and then you can simply come back here and you can say, I want to print this n here. So for each is a part of the list interface. You can simply say for each, and then it will give you one value, and you can do whatever you want to do with that value. So I'm just printing it here and here. And if I compile this and run, you can see we got the same output. So we have three options now. We can use a normal for loop, we can use the enhanced for loop, or we can use a for each method. But how exactly this for each method works? We'll see that in the next video. So let's understand what this for each and what is this statement inside this. This looks weird, right? Yeah, I know we have worked with lambda expression. It looks like lambda expression, but what is happening behind the scene? To understand that, what I will do is I will just remove the entire for loop. We don't need that. And let me just push this down. This will be required later once we talk about how do we stream API. But at this point, let's only focus on for each here. So what I will do is, first of all, I will remove this section, or maybe I can just comment it so that we can see this later. Here at this point, let's try to use nums. So when I say nums dot, you can see there is a method called for each. Now for each method, if you see, and if you go to this definition, for each basically got introduced in 1.8, okay? And what it basically does is, it takes an object of consumer. You can see for each method, okay, let me just go to definition itself. So you can see for each method takes an object of a consumer. Okay, that sounds weird, right? Let's see what this consumer is. So if I want to work with for each, I need to create object of consumer. Okay, so the moment you say you have to create object, I can simply say consumer, and you can see consumer is a interface which belongs to a package java.util.function. Okay, that's new. And this is an interface which is a functional interface. So that means lambda expression will be applicable. And the only method we have to work with this is accept. Okay, that means I have to create object of consumer which takes the type of integer, because if you see the consumer interface, you have to specify type as well. So I will say consumer integer, and then I will come back here. Let me say con is equal to, how do I create an object of it? It's very simple. You can say new consumer. Now, since this is the interface, we have to define the class, which is anonymous class. Okay, that is also simple. The only thing is we have to define a method also. The method name is public. Void, is it void? Let me just check once. Consumer has a method called accept, which is of type void, okay, which returns void. And the method name is accept, I will say that. And then it takes the integer value. I mean, whatever type you mentioned, I will say integer, let's say n. Okay, now the thing is, once you got this consumer object, you can simply pass an object in this. I can simply say con. So for each needs an object, and we are passing the object of consumer. Our job is done, right? The thing is, when you talk about for each, what it does is it gives you one value at a time, okay? Now, whatever value you are getting here, or for each is giving you, that goes into this consumer object. And the consumer object has only one method, which is accept. Okay. Now, this accept will accept a number. That's right. The for each will give you a number, right? That goes into this n. Now you can decide what you want to do this with n. Okay, I would say I just want to print it. I mean, that's your choice. You can do whatever you want to do with this n. At this point, I'm just printing it. Okay. And now let's see if this works. I will just go back and clear the screen, compile, run, and you can see it is working. You are able to print all the values. Okay, and you can see the entire code, all the other codes are commented. So they are not running. This code is running and it is printing all the values. Makes sense. Now we also know that the consumer interface is a function interface, which means we can use lambda expression here. That also means from here to here, we can delete this part. Let's delete that. Let's delete this curly brackets. And I hope till this point you got a mastery in lambda expression. And I can give an arrow here. That looks good. And since we only have one statement, you don't need to put curly brackets. I will remove that as well. And I can write everything in one line. That looks cool, right? And then we don't even have to mention the integer here. And we don't even have to mention a bracket when you have only one variable. Makes sense, right? Let's see if this works. After doing all those changes, compile and run, there's no problem. Now, what we're doing is we are assigning this expression to con, right? Now, whenever we have con, we can actually use this. So instead of using con here, I can simply use this particular code and replace this con. And that's it. We don't even have to create a reference for the consumer. And this is what we have seen earlier, right? If you compare the earlier example, this looks similar. In fact, exact same. So that's how your for each works. It gives you the value, that is your n, and you can do whatever you want to do with that n. You can print it, you can add it, you can save that in database. That's your choice. Okay, so that's how basically we use a for each. Now, once you understand for each, let's go for the actual Stream API. So basically we were having this collection or a list, right, where we have values, and then we were able to print that with the help of for each. And now we know what is happening behind the scene, right? What if you want to do this with a Stream API? Now let me just give you the introduction of Stream API here and how it looks like. So if we talk about Stream is an interface, right? So if you can see, we have seen that before as well. Stream is basically an interface, right? The thing is, if I go back to nums and if I say dot, you can see now in the list, we got this new method called stream. Again, before 1.8, the method was not there. It was introduced later, but we got this method called stream. Now what this stream does is it gives you, or it returns the object of stream. Okay. So that means if I want to accept the values, I can say stream of integers, and let me just name this as S1. So this is our stream, which is called S1 here. And we got all the values. So whatever values you have in this list is available in this S1. Now with this stream, you can perform any operation, and the beauty is it will not going to affect the nums. So whatever changes you make to the stream, if you change the values, if you double the values, it is not going to affect nums. Now why this is important? See, sometimes when you have a data and then if you want to perform some operation, it's not like always you want to change the existing values. Remember when we talked about threads, when you have multiple threads and then you are performing some operation, mutation, it's not good, right? So whatever changes you want to do that in this stream and use it. At least you have your original values with you. Okay, now that means I can also print the entire thing with the help of for each. I can say S1 dot for each. Mind you, again in the stream of S1, we got all the values which are there in the list. And let me just try if that works. I will say compile and run, and you can see we got the values here. Now, one of the thing about stream is once you use the stream, you can't reuse it. And that's why the name is stream. Example, if you talk about the flow of water, the stream, right? Once, example, let's say if you're sitting near the river or the bank of river, basically if the water passes, you can't retouch the same water. In the same way, once you have worked with a stream, you can't reuse it. Example, let's say if I try to print this multiple times, let's say 2 times, it will not give an issue with the list. Okay, you can simply say nums dot for each multiple times, there's no issue. But if you try to do that with the stream once again, you can see you will get an error. Compile time, there's no issue. Run time, it will work once. The second time it will say the stream has already been operated upon or closed. That means you can use stream only once. Okay, that makes sense. So we can't reuse it. But then what is the benefit of using stream here? The benefit is, Stream provides you a lot of methods to work with. Example, if I say s1 dot, we have methods. Example, we have methods like filter. Remember when we talked about the earlier example where we were removing all the odd values, or we wanted to only get even numbers? We can do that in stream as well. Now how it looks like? I can simply say s1 dot. We can use a method called filter. Okay, now what this filter will do is, filter will say, okay, I want to apply the filter here, but give me a condition. So for any particular value, let's say n, what you want to do with this? So I can say, I can use a lambda expression. I can say n mod 2 equal to 0. So I only want a even number here. So this filter, and if you jump to this filter, you can see filter returns a stream. So what we are doing is, when we say s1.filter, it will give you basically a new stream to work with. Well, let's say s2. Again, as I mentioned before, s1 is used, right? So when I say s1.filter, your s1 has been used now. Now you got a new stream. Now this s2 basically will have only the even numbers. Let me prove that. Let me print s2 and let's see what values you get here. So I will say compile and run. You can see we only got even numbers. Now see what we are doing here. We'll have a separate video on this, how filter works. But the idea is the filter is filtering the value based on the even or odd. You can specify whatever logic you want to. But at this point, I'm just specifying a logic of a condition of even, right? Now, once you got this stream, I can create another stream where I'm doubling the value. I can say stream and I can say integer, let's say s3, because it will give you a new stream. I can do the operation on the new stream, which is s2. On s2, basically, I'm trying to double the value, right? So you can do that with map. In this map, for whatever value you get, you can perform some operation on that. At this point, I'm just doubling the value, right? As I mentioned, you can use any logic. At this point, I'm just doubling it. And now let's try to see how this stream works. I'm saying S3 now because you can't use S2. S2 is done. And if I compile and run, you can see we got double the values. We got 8, 4, and 12. So yeah, stream provides you this amazing methods on which you can perform the operation on one stream, it will give you a new stream. You can perform the operation on the other stream, it will give you a new stream. In fact, you can also use some methods which will not give you a stream, but a last output. Example, let's say, if I say s3 dot, there's a method called reduce. Now in this reduce, if you say 0, comma, again, I will explain this logic later, what I've did, but let's say if I try to do this, if I say c, comma, e, c plus e, now what this reduce will do it, again, don't focus on the logic now, just focus on my reduce. This reduce will not give me a new stream. This reduce will give me a value of type, whatever type you mentioned with the integer, with the stream, which is integer. So it will give me int value. So I can say int result equal to s3.reduce. And instead of using a for each, now why we can't use for each? Because reduce will give you a single value, which is there in the result. I can simply come back and I can print the result. And I can just compile this code and run, and we can see we got 24. Again, let me repeat, just ignore what is happening inside. We'll talk about this in the next video. What is happening inside this? Idea is stream makes your work easy by having these functions. We have a function like filter, map, reduce. Now, I don't know if you know about this concept of big data. Example, in this world, we are getting so much of data, right? Now, if you want to use all this data, first of all, you have to apply the filter on it. There are some wanted data, there are some unwanted data. So you can apply the filter. Once you apply the filter, the data which you got, you can transform it. Something meaningful. You can do that with the help of map. And then you can make a graph out of it, right? With the help of something called reduce. And then we were able to print the result. Let me just see if that works. Compile, no issue, run, and you got 24. And this is the same logic which you have done here. Can you remember? We have used a for loop which was giving 24. The same thing we have done with the help of stream. Now the beauty is you can actually write everything in one line. Let me show you something. I will just comment this entire section, and here what I can do is I can say nums dot, I can say stream. It will give me a stream of values. On the same stream I can say dot and I can apply a filter, and this filter can be we can be any logic. As I mentioned, we are going for even numbers. 0, and on the same stream, because see, nums dot stream, nums is the least, right? The stream method will give you the stream. On that stream, we are applying a filter. Again, we will get a new stream. And on the new stream, we are applying a map, which is n into 2. And then this stream will give you a new stream on which you are applying reduce, where we are saying 0, comma c plus e, or c comma e, which will be giving me c plus e. And that's it. This reduce will give you one value, right? And that one value you can store in a result. So this nums.stream, let me just give a tab here. Yeah. So this basically nums.stream will give you a stream. On that stream, you're applying a filter. On that stream, we are applying a map. On that stream, you are applying a reduce. And then you got one value at a time. And this looks much better than the for loop. I know for the newcomers, this will be difficult. But once you get used to it, you will always prefer to use stream. Okay. And one of my favorite trainer or mentor says, Venkat Subramaniam says, it's not difficult. It's just unfamiliar. Okay, so this is how it works, and you can compare with the for loop, and this looks much clearer. In fact, it's much more readable, right? On a stream, you are applying a filter. On that filter applied, you are applying a map, and then you're reducing. But what is happening behind the scene, that we'll see in the next video. And let's try to understand what is happening here. When you talk about filter, what it does. When you talk about map, what it does. We understood what it does in the for each. It takes the object of consumer, but I'm not sure what it will do here. So what I will do is, just to simplify the code, I will remove everything. And also, let me remove all this thing so that it will look cool, simple code. Okay, so let's go step by step. If we talk about this filter, and if I say, okay, let me just go to filter. And you can see filter needs an object. You can see there's a parameter. It needs an object of a predicate. Now, what is predicate? I will just go back here, and if I type predicate here, so if I say predicate, and you can see it belongs to a package java.util.function. And if I click on predicate here, predicate is an interface which has a method called test. It returns you a Boolean value. Okay. Now, based on this Boolean value, it will say, okay, it can be either true or false. If from a stream, when you apply a filter, for a particular value, if this is true, it will go ahead. Otherwise, it will stop. It's something like applying a filter on a river. So let's say if you have a river flowing and then you have to apply a filter there. And if you want only the pure water to pass, all the garbage will be stuck somewhere. You can do that with the help of a filter. I hope that makes sense, right? Let's implement predicate here. So of course, predicate needs a type you want to work with. And then let me say this is P is equal to, and I will say new predicate. Now this predicate is an interface, so we have to of course define it, but what method it has. So if I go back and if I say quick fix, add the implementation method. So the method name is test. Okay, remove that. So method name is test, and it takes the integer value, and based on some condition which you can specify is it true or false. So what I can do here is I can check if the value t, or whatever value you want to have, let's say the value is n naught. I don't like t later. Let's go with n. So if n is mod, n mod 2 is equal to 0, in that case, return true. I can give a tab and I can say else, return false. Our problem solved, right? Okay, so if it is true, if the value of n is even, it is true, then if this is true, I will return true, or I will return false. And now what I can do is, instead of this condition here, I can put P, right? Even that should work. Let's try, compile and run. And you can see it is working. So basically this filter needs the object of predicate, which specifies the logic of when to pass the value and when to stop the value. Now if I try to reduce this code, don't you think this condition here itself returns true? Then why to write such a big line? We can actually return n mod 2 equal to 0. Because see, ultimately, we need a Boolean value, right? It can be true or false. So we can do this. Also, the predicate itself is a function interface. That means we can use lambda expression here. So we can remove from here to here. We can remove the entire part. We don't even need to specify the type. And we don't need this curly bracket. We can put an arrow here. And then, since we only have one statement, you don't even need curly brackets. You don't even need a new return keyword. We can write everything in one line. And since we have only one parameter, We can remove this one, and you can see the P is equal to this expression. And whenever you have the expression, or whenever you have P, you can write this expression. And this is what we have earlier, right? So now we know how filter works. Let's see how map works. If I go to map, map needs object of a function. Okay, what this function is. Now function is this functional interface which takes two types. Okay, makes sense. And there's a method called apply. Okay, so what I can do is I can have the object of map, or not the map, the object of function. Now this function takes two types. One, it is what it accepts and what it returns. And say, let's say fun, because that is fun, and new function. And again, this is a function interface which has only one method. Let me just add that here. So this is a method which we want to override, which is apply. Now what I want to do, whatever value you get, let's say instead of TV, let's say n, whatever you want to do with this n, it will just apply that value. So let's say for this n, what I want to do is I want to return n into 2. So whatever value I'm getting, I just want to double it. Again, as I mentioned, logic can be anything, but I'm doubling it here. Okay, makes sense. And we also know that this is a functional interface. Okay, first of all, let me take this fun from here and put it here. So we can say fun, and let's see if that works. I will say compile and run, and you can see we got 24. It works. What we can also do is from here to here, this is a functional interface, so we can remove this part and we can use lambda here. I will just do that quickly. Now we have mastered lambda and we have only one statement which is returned, so we can remove that. We can remove this curly brackets, we can remove this integer, we can remove this brackets, and this is what we got. And now we know wherever you have fun, you can write this, and this is what we had before. So we don't even need this. Right? The same thing can be done for reduce. If I click on reduce, you can see reduce takes two parameters. One is the type and second is the operation. Okay. Now what is this binary operator? So binary operator basically is, it extends by function. By function is a method called apply. Okay, let me just simplify this for you. I know this is a lot of implementation there. Let me simplify this thing. Now when you talk about reduce, how do you reduce a value? Example, let's say if I ask you to add three numbers, let's say 1, 2, 3, how will you add them? Now in your mind you're doing this. So if I say 1, 2, 3 and let's say 4 also, how will you add them? Of course you cannot add all the values at the same time. You add two values at the same time. So first of all you will add 1 and 2 which will give you 3. Then you will add 3 and 3 which will give you 6. And then you will add 6 and 4 which will give you 10, right? So you add two values at a time. Or maybe if you want to simplify this, you can start with 0. So you can say 0 plus 1 is 1, then 1 plus 2 is 3. Okay, so you have to start with the initial value. Remember when we created int sum, we have assigned the value of sum is 0, that is this 0. And every time you will simply add two values. So if I want to add two values, can I say this is C and E? The carry, because see, this 1 is a carry here, right? This 3 is a carry. This 6 is a carry. This 10 is 10 is the output, of course. But this 1, 3 and 6, they are carry, which can be represented with the help of C. And then we have this E, which is the element, right? C and E. And what you're doing is you just have to say C plus E. And that's what we have done here. The 0 is the initial value, what you want to work with, this value. And then the C and E are the two variables which is going to work with this thing. And the C plus E is the operation. It's that simple. Okay. Of course, you can do this with the implementation, but I think you got the point, right? So stream is cool, right? It works with, we can apply multiple functions here. In fact, let me show you one more thing. What if I don't want a int result in between? I want a stream itself, but I want the stream to be sorted. So I will say integer and I will say sorted values. But I don't want to apply reduce because reduce will give you one value. I only want to filter them based on the condition, and then I want to say sort. That's it. The moment you say sorted, you will get a sorted stream, and maybe you can also print this values directly instead of using a for each. Let's try that. Compile and run. Oh, we have to use for each. Okay. So I will say sorted values dot for each, and you can say whatever value you get, just print it. Okay, let's try, compile and run. And you can see we got the value in sorted format. So basically we have multiple methods to work with. In fact, there's one more thing. What if you want to do the filtering but with multiple threads? By default, you have only one thread, right? What if you want to use multiple threads? In that case, there's another function called parallel stream, which will create multiple threads for you to make this faster. The only thing is, when you say sort, parallel stream doesn't make sense because sorting will need all the elements together. So don't use parallel stream when you want to sort. But yes, if you want to filter, parallel stream works. Okay, so yeah, that's how we use Stream API, and I hope you got the idea about map, filter, and reduce. In the previous video, we have talked about the parallel stream, right? So in this video, let's try to expand the example and let's see the power of it. So what we will do is, as I mentioned before, if you want to work with parallel stream and if you want to see the effect it can create, you need a huge amount of data. Now at this point, I don't have any huge amount of data. So let's create huge amount of data. So what I'm saying is, let's create a list of numbers. So I will say list of integers here. And I will name this, okay, first we have to import the package. Let's do that quickly. So I want this package and let's say nums is equal to new array list. Now at this point, this list is empty, right? Let's fill this list with how many values? Let's say 10,000 values. Can we do this? Let's try. When you create a list, it will have some capacity, right? So initially itself, we can say I want to go for 10,000 values so that it will create a list for you, which will have 10,000 values. I mean, 0 values, all zeros. And how do you add 10,000 values? Now that's a tricky part, right? Of course, you can simply say nums.add and you can add all the values, or we can simply use a random class to do that. So we'll run the loop from start to end, and every time you will add a random number. But the question arises, how will you get the random number? So we have basically a class called random, and I can say ran equal to new random. We can use this particular class which belongs to a package java.util, and it has a lot of methods. If you can see ran dot, there's a method called nextInt. So basically you can specify what number you want. I mean, you can specify what type of number you want, and it will give you that number. And also you can mention the bond or what the last value you want from this. So if you go to nextInt, you can mention the upper bound. And that's what we are doing here. So basically, we are saying I want the upper bound to be 100. Okay, but then I don't want to add one value, right? So this will give you one value and you can add that in a list. We want to do that 10,000 times. So of course you have to use a loop here. So I will use a for loop and I'm going to start from, let's say I equal to 0 and I less than equal to, or maybe I can start with 1 because we don't want to work with index numbers. And I want to go for the last value, which is 10,000. Or in fact, the better would be if you can create a variable called, let's say size, let's say 10,000. And what you can also do is you can put an underscore in between if you want to differentiate the number of zeros you have. It can be very confusing. So we got this new syntax where you can put underscore in between numbers so that you can differentiate or you can count it easily. And everywhere, instead of using this number, I can use size, and here also I can use size, and I can say I++. So in this particular loop, basically I want to add the element in the num. So I can say nums.add, but what number I want to add? Now that is something which random class will give us. So we can say ran.nextInt. By doing this, you got 10,000 values in the list. If you want to see that, you can actually print nums and see what values you got there. So I will go back to my terminal. Terminal is here. I'll reduce the font size a bit. And I can take this on right side. Okay, so first of all, let me compile the code. So I will say javac streamx.java. That's the file name we have. So compilation done. Let's run this and let's see what happens. So I will say streamx, and you can see we got 10,000 values here. Again, the value doesn't matter. But what we want to do with these values? So what I want to do is, I want to multiply every value here by 2. I mean, that's the simple thing we can do, right? Of course, we can do a lot of different stuff, but here we're just trying to multiply this number by 2. And then we'll also add all the values. And we have done this before, right? So get the value, multiply by 2, and find the sum out of it. And we have done that before, but with less number of values. And in this video, I want to also introduce you to a new method called map to int, which will give you a way to add the values. We have used reduce before, but the syntax is complex, right? So let's make it easy now. Okay, so this is the output we got, but we don't want all this output. I actually don't want to print this anymore. I will just not print it. But what I want to do is I want to add all the values, right? And how do we know if we are getting the right value? So initially we'll not be using parallel stream. We'll use a normal stream and we'll put that here. So what I will do is I will create a stream, or maybe I just have to find a sum, right? So I will say int sum equal to. Now if you go back to the previous video, the way you can do that is first of all take this nums, apply a stream on that so that you will get a stream object. Then on this stream object, basically you apply the filter. Okay, we don't want to apply a filter at this point. Let's use directly take all the values and multiply by 2. So we can simply use map, and I can simply map this to I into 2. So what we're doing this by, we are just multiplying the number, and then we can use reduce here, right? So the way you can do reduce is this. You can use reduce and you can pass the carry, the first value, which is the identity, and then you can use the expression. You can say for these two values, I'm not going to explain this here because we have done this before. So I will say plus E. So it will give you sum, right? Now this is one way of finding it. So I will say this is sum 1 so that you will have some number here. And we can print this sum 1, or maybe we can print at the end everything. The next thing we can do is, I wanted to introduce you with one more thing, right, which is map to int. So basically what you can do is, if you don't like this particular syntax, which is a bit tricky, what if you can just get a method called sum? But this sum method actually belongs to another object. So there's something called int stream. I will show you what I'm talking about. So I will say sum2 is equal to, let's do the same thing. I will say nums.stream, and then I will apply the map here. Again, the same thing. I will use I into 2. And then instead of directly applying reduce, I want to use sum. But unfortunately, if you do sum, it will not work. The reason is when you talk about stream, it can be of any type of stream, right? Of course, we are using integer here, but it will think about any type of string. What we want to say is, hey, I want to perform some operation on integer. So we can convert this entire stream with the help of this method called map to int. Now what map to int does is, if you click on this, map to int, which is here. So if you can see, map to int returns you an object of int stream. And when you click on int stream, you can see there are some methods here. Basically, I want to find a method called sum. So there is a method. Okay, well, I'm not going to find the sum method. Yeah, so there's a method called sum, and this will basically add all the values. So internally it is using the reduce. That's what we are getting here. But anyway, we don't want to use reduce, we want to use sum. So that is possible with the help of map to int. And here I can just take the value and apply as it is. I'm not changing anything. I'm saying get a value and convert that into int. That's what it will do. And then once you do this, you can use this method called sum, because sum is applicable only when you return the int stream, not a normal stream. So it will give you the same value. And let's see if this gives you the same value. So I can say s out. Let me print sum1, and also with a space in between, I want to print sum2. And of course it will give you the same values at the end. So I will just compile this and run. You can see both are giving the same value. So of course both does the same thing. And it was quite fast. It is depend upon the system which you are using, how fast it should be. Fortunately for me, I'm using a good machine because I have to record videos. Unfortunately, this machine is so fast, I'm not able to see much difference, right? But I will show you that difference by adding some extra time. But if you really want to see the speed, we can also use parallel stream here. So I can just simply copy this and paste it here. We'll say this is sum3. The only change I'm going to make is by saying this is a parallel stream, not a normal stream, a parallel stream. And here also, of course, I want to print the value, the sum value, which is sum3. And let's see if it is giving you the same value. So I've saved it, compile, run, and you can see we got 3 values and all the 3 are same. Now if you're comparing this with the previous values, mind you, we are generating random values. So the values which you're getting every time are new. Okay, but we have to make sure that all these 3 are giving the same output, and which they are. Cool. But then how will you see the speed? Now first of all, let's only work with the sum2 and sum3. Let's ignore sum1 at this point so that we can have a smaller code. I don't want to print sum 1 anymore. So sum 2 and sum 3, that's what you're focusing on. Now, how will you see the difference? See, if you want to see the difference, we can set the timer, right? Before this, after this, and then we can set the difference. So what we can do is we can create a variable here. I will go with the variable type long, and I will say start sequential because I want a time. And the way you can get the time is with the help of system.currentTime millis. So what it will return is the number of milliseconds, the current milliseconds from 1970s. Okay, so because that's where the Unix epoch came into existence. So basically it will give you the current time in milliseconds. And then once you are done with this operation, I can say long and sequential is equal to, again, the same thing, which is current time millis. I will just copy this and paste it here so that you don't have to type again. And then I can print the time. So I can print the time here, or maybe I can print the time at the end somewhere here. I will say sequential stream. It is taking time, which is end minus start. So it will print the number of milliseconds it takes. The same thing can be done for this particular parallel stream. So what I can do is I can just copy this and paste it here, but you have to change the name to it. So I will say this is start para, and then I will apply the end as well. So copy and paste here, and this will be end para. Okay, and then I want to print this system.out.println, but here it should be end para minus start para. So it will print the parallel sequence. So I will say this is para. So basically the first one will print the amount of time it took to do the first operation, and this one will print the second operation. Okay, now I want you to guess which will run faster. Is it the sequential or parallel? Of course, logically it should be parallel, right? And I'm not sure which one will take more time. I'm just guessing. See, the thing is, whenever you have a simple operations like this, parallel stream will take more time than stream, is because parallel stream is responsible to create the threads, and creating threads takes time, right? Sequential stream is not creating multiple threads, it's working with single thread and say, okay, let's get the job done. And for your computer, computation of normal numbers is very easy. So I'm guessing the parallel will be faster than the sequential. Sorry, the sequential will be faster than parallel. And let's see what you get. So sequential is taking 6 and parallel is taking 4. Okay, I was wrong. So we are saving those 2 beautiful milliseconds. But what if I run this every time? Okay, looks good. Parallel is running faster. So that means my system was able to create threads faster. I want to know what you are getting in your machine. It might be different. I'm very curious to know what you are getting. But let's say every time you are performing this map operation, and maybe it is taking some time. For us, it is very fast. But what if every operation here takes 1 millisecond? Then how much difference it will create? Let's try that. First of all, how will you make sure that it takes 1 milliseconds? So what we can do is we can, on purpose, add a delay in the operation, assuming that there's a complex operation going on. So it will take some time. So since we are going to write multiple statements, I'm going to give some curly brackets, and we have to go back to return because that's how things are working here. So if you want to write multiple statements, you have to put the curly brackets as usual, and we have to also make sure that you do return the number. But before this, I want to add a space. So I will say try and catch as well, because I'm going to use thread.sleep, which basically throws a checked exception. So you have to make sure that you are handling it. At this point, I'm not handling it. I'm just saying catch block is there. And inside this, I'm going to say thread.sleep, and I'm going to sleep it for 1 millisecond. And since I want to make sure that it will not consume much space, I can write everything in one line. I just want to save some spaces so that you can see the entire code. So basically, okay. So that's my, okay. So my IDE is not allowing me to do that. It is doing auto formatting, but that's fine. Okay. What I will do is I will just keep it like it is. I want to do the same thing in the parallel map as well. So I will just copy this and replace this line with this thing, with the threads timer added or delay added. Okay. And now let's see the difference. First of all, it will take a lot of time. It should take around 10 seconds. I mean, that's what I'm assuming. Because we have 10,000 values, we're adding a delay of 1. So let's see. So I will first compile the code and run. It is taking time because we're adding a delay there. It is doing the computation behind the scene. Okay, waiting. Should we wait for 10 seconds? And maybe I will not even cut the video in between because I want you to wait with me. Why should you have all the fun? Okay, so look at the time it took. So the sequential took around 12,000 milliseconds. In fact, 13,000 milliseconds is because we are applying a delay there. And since there's a delay, it will work with one value at a time. The parallel stream says, okay, I know there's a delay and I can't do anything with the delay, but at least I can do parallel things at the same time. And that's what is happening there. And it took around 1.4 seconds, and this one took 13 seconds. And that's the beauty of the parallel stream. So again, you can do this only when the values are not independent. In fact, the operation is independent on the values, not dependent. So sometimes if you have dependent values, like if you want to sort the values, then parallel stream will not work. So use it only when it is required. Don't unnecessarily create bugs in your system by using parallel stream when you have no idea what output you're going to get. So yeah, that's it from this video where we talked about parallel stream, and let's focus on some more concepts later. Now let's talk about a class called optional. Now this was introduced in Java 1.8, and the question is why? Why we have to get a new class? Now to understand that, let's take an example here and then it will make sense. So let's say we have a main class here. We have a class where we have a main method, and in this, let me create a list of values. So I will say list of string. Basically you have to import the package as well. So I will do that here. And then what I'm going to do is I'm going to create a list of names, and let me have some values. Let's say I will go for the arrays.list to create a list there. And in this I want to add some names. Let's say I want to go for a name Naveen, Lakshmi, John, and let's say Kishore. Okay, so we got this 4 names here, and then what operation I want to perform is I want to print the list of names where they have, let's say, X in their name. Okay, so the way you can do that is very simple. We can use Stream API here, and what it should return is string values. So I will say string one name. It should return one name. I'm expecting only one name here, not list of values or something. One name, where I can say names.stream, and then I can say I want to apply a filter. So basically whenever you want to find something and if you want to filter something, we can use this filter method. Basically you can pass the value. So whatever name you are passing, let's say n, let's say str maybe in that case, and I want to check if it is in this str, do we have a letter or a word or a sequence of characters where you have X. So I'm just trying to find X, and if it is there, give me the first value. So it may happen that you might be having multiple values, not just one. You have multiple set of values, okay? And you want to find just one. So you will say find first. So let's say if you have 3 names in which you have X, it will give you 3 values. I want the first value. So we can say find first. But the problem is, if you can see, find first is not giving you a string. It is giving you an optional string. But question is why optional string? So if I go back here, you can say it returns a type of optional. What is optional? Optional is a class which was introduced in 1.8. Now it came into existence just to avoid one of the most famous error which we all hate or love, that's our choice, and the error is null pointer exception. It's because whenever you try to perform the operation on a null value, it will give you null pointer exception. So let's say in these names where you have 4 names, you got one name, we have X there. But what if you don't have any name which has X? So this basically name will be null. And we don't want it, because when you have null, it will give you null pointer exception. And that's where they introduced something called optional. So what you can do is, you can make it optional to make it work, and we have to import the package as well. So now you can see there's no problem. So we are accepting a name which is a type of string, but the main type is optional, because this optional can be empty or it can have some values. Now how do you print a value here? So what we can do is we can say name dot, if you want to get the value, you can say get, it will get the value and you're printing it. So what I'm going to do is I'm going to compile this first, which is optional x.java, and then I'm going to run this. And when you say enter, you can see it is giving you one name, which is Lakshmi. But what if you don't have any name where you have x? So Lakshmi can also be returned as this. This is one of the spelling for Lakshmi. And now if I try to compile this and run, and you can see we got an error. So basically when you say optional, it will give you a different error. It says no such element. At least we have not got the null pointer exception. But if you want to avoid this, you can do this. So you can say name dot, and we're trying to print name, but also we are trying to say or else. So you can say not found. By doing this, what you're saying is, hey, if you have a name in there, print the name, or if we don't have any value, print not found. So in this case, you will not get any error. So when you compile this and run, you can see it says not found. But let's say if you do have that value there, if you have x, and if you compile this and run, you will get the name. So basically what we're trying to do is we are trying to avoid one of the most famous error, which is null pointer exception, and for that we got optional. But let's say if you don't want to follow this pattern here, you just want the value here. So what you can also do is, now since we know that the type is string, one thing we can do, we can add one more thing here called or else. So we can say not found here also, even that works. So we're just trying to avoid optional here. So it will give you optional, but then from this optional you are returning or else here. So you don't have to do that here. So you have two ways. You can either use optional class and then you can find the value, or you can directly mention or else, because see, find first will give you optional. On that itself we are applying or else, which means it will give you the value here itself, or it will give you or else. Let me see if this works first of all. So I will just compile this and run. You can see we got a name, but what if you say Lakshmi, we don't have x, and run, it says not found. So yeah, that was optional for you, which was introduced in Java 1.8 with of course Stream API. In this video, we'll talk about method reference. Now this also came in Java 8, so let's understand what exactly it is. So what I'm going to do is, let me create a list of names here. Of course, we'll go for the same thing which we have done before. So I'm going to say this is list, we have to import the package, and these are the names. Okay, what are the names we want to go for? So I will say this is arrays.asList, and here let's have some names. So I will go for Naveen, I will go for Harsh, I will go for John. So let's say we have this three names here. And what I want to do now is I just want to print them, but I want to print them in the capital letters. So basically we have this name where we have the first letter capital, remaining are small. I want everything to be capital. The way we can do that is we can run this in a stream, or maybe I will just say capital and then convert that into again a list of string. And I will say this is unames because it will give you the names with the upper letters. Okay. So I will say names dot stream, we can use stream here, and then dot, I want to map it, right? So I can simply use map. Now how do you convert such something to a capital letter? So basically in the string class, we have a method called toUpperCase. We can use it and we can convert that. So what we can do is, for every name which you're getting here, so from these names, for every name which you get, I just want to make it uppercase. And the way you can do that is you can say name dot to uppercase. Of course you can do uppercase or lowercase, that's your choice. And then once you do that, you want to return the stream in a list format. And to achieve that, we have a method called toList. Because see, this map will give you a new stream, right? And then what you're doing is you're saying, okay, I got this new stream, I just have to convert that into a list again. And to convert a string to list, we have this method called toList, which will convert into a list. And once we have that, I can simply print these names and see if that works. Okay, till this point we have not used method reference. We're just trying to build up the example here. So how do we run this? So we'll say Java C, the file name is method reference x.java, and let's compile this. Okay, compiling done, let's run this and see the output. So you can see all the names are capital letters now, or uppercase. Now let's try to understand what is method reference and how can we use it. Now here if you see in the map, what we are doing is we are taking a name. So basically we're taking a variable and then we are calling a method. So basically with that particular variable, we are just calling a method, right? If you just want to call a method for a particular variable or for a particular object, what your Java says now is, why to even all say all those things? What you can only do is just mention for every variable what you want to do. So I will say for every variable I want to convert that into uppercase. That's it. Just mention the method name, not even the brackets. So what you're doing is you are passing a function to a function, and that's where this functional style programming came into picture. So basically what you're doing is you are passing a function name, which function you want to call, and that's it. So map will give you one value at a time, and you are saying for every value I want to find two uppercase. But also we have to mention where that method belongs to. So this method belongs to a string class, and the object for string class is name. But we have to also mention where this two uppercase belongs to. Now this two uppercase belongs to a string class. So I can say string : two uppercase. Now this is called method reference. So we are saying for every element which is coming from the map, just convert that into uppercase. Okay, and then we are just specifying the method name, and we have to mention which class it belongs to. It belongs to string class, and that's it. If you can see with the new code which we have written, compile, run, it works. I mean, not just here, you can use it anywhere you want. So let's say I don't want to print this like this. Maybe I want to use for each. So what I can do is I can say new unames dot for each, and inside for each, if you remember, what we normally do is we take a variable, let's say I represents each value from this list, and then you simply print it, right? We print it by saying I want to print this I. So basically this is how you print the values. So it will print the values for you one by one. But here also we can use the method reference. What we can do is instead of this we can remove all these things. The only thing you have to mention is which method you want to call. So I want to call the print method. That's it. So for each will give you one value at a time. You just mention what you want to do with that method. Mention the method name, who is responsible to take the value and do something with it. But why it is not working is because you have to mention where this method belongs to. So this method belongs to system.out : So now what we're doing is we are specifying this system.out here, that println belongs to system.out. And now if you compile and run, it still works. So basically what is method reference? Method reference simply means that you can pass a method name inside the method by specifying this method is responsible to do the work for you. The only thing you have to do is you have to mention the class name or the object name to use it. So yeah, that's it. That's how the method reference works in Java. So till this point, we have talked about method reference and we know how it works now. So basically, let's say if you are using any stream function and that function will give you one value at a time and you want to do something with that value, we can use a normal Lambda expression, or also we can use a method reference. So what we are doing here is when your map is giving you the value, you're passing that value to uppercase method. And that's what we are doing here. So we don't have to mention the variable name, and then we don't have to mention the parameter name, is the round brackets. The only thing you have to mention is the method name, and we have done that. And now let's try to understand what is a constructor reference. Now that's something different, right? Okay, so what I'm going to do is to understand that, let's say we have this list of names and I want to create the student object based on this name, or a person object, doesn't matter. So what I will do here is, first of all, let me create a very simple class called student. And just to keep it simple, in this class, let's say we only have two variables. So I will say private int private int name, private string name, and private int age. So let's say we have these two variables, and for these two variables, I need some constructors. Of course, we can create different types of constructor here. So what I will do is, I will go to source action, and I will say I want constructor. So basically I need two constructor. One is a default constructor, and also I need one constructor which will be a single parameterized constructor. So I want a constructor with name, because I want whenever I create a student, at least it should have a name. Okay, that's what we want here. Or maybe I can just skip, or maybe let's keep it there. And then for this, we also need getters and setters. So I will just go back here and say generate getter setters. So we'll just click here. For both the variables, I need getters and setters, and also I need to have a toString method if I want to print this. So I will say source action, I want a toString method for both the variables. Yeah. Okay, so we got all the methods required for the student class. What I want to do is, with every name here, I basically want to create one object for each name. So in total, I want 3 objects. Or can we say I need the list of objects, list of students. So I will say list of type student, and I will say these are students equal to new array list. So basically I got the list of students, but they are empty now. So at this point, we don't have any student. So what I want to do is, based on these names, I want to create them. And the way you can do that, if you want to use a simple collection, if you don't want to use stream, the way you do that is you hover, you go through all the values from the names. So I will say string name colon names. And then every time this loop runs, you will create a new student object. So you will say new student, and you have to pass this name. So whatever name you are passing, it will create a new object. And then the same object you will simply add into a student's array. So you will say student dot add, and this is what you can do. So this is one way of doing it, not students. Yeah. And then once you complete this loop, I want to print it to see if this is working. I want to print all the students, and let's see if I get those objects. So I will just go back here and say compile this. I'm still in the same code of method reference. We could have gone for a new file, but that's fine. So I will just compile this, no problem, run this, and you can see we are getting 3 students with different names, Naveen, Harsh, and John, and the age is by default 0 because maybe we want to add the values later or change the value later. At this point, I got those 3 students. But we can also do this with the help of Stream API. So let's see how do we do that in Stream API. So what I will do is I will create a students, I will assign the value to students, but with the help of streams. I will say names dot, first I will convert that into stream, and then I will be using a method called map, because that's how you basically, see, you are getting a name which is of type string. Now with that string type, you want to create a student object. So what you will do is you will say a map for every name. I want to create a new student. So that's the student object which we will get. And let's say I'm passing a name here. So what this will do is, this names will give 3 names, right? So the stream will have 3 names. This map will take 1 name and create a new student object, right? So at the end, when you run this entire stream, you will get 3 student objects with those 3 names. And then once you got the entire stream of 3 students, you will convert that to a list. So you will say to list. So now in this students, you got all the students. Okay, let's verify if this works. And yeah, it works. So even this works. Now this is how basically you can use stream to convert a list of students to a list of objects, right? That's the beauty about this map function. But then we can also use a constructor reference here. So what you can do is, see, anyway, what we are doing is we are taking a name, which is a type string, and then you are creating a new object with the help of new keyword. Constructor reference says, instead of doing this, you can simply mention which class you're working with. You can simply mention the operator you want to perform. So I want to go for the new operator. But this new should be creating object of student. So you will say student colon new. It will create a new object for you. And this syntax looks better than the Lambda. But again, sometimes it is difficult to read if you are not aware about method reference or constructor reference. But this is what you can do. So the earlier syntax, let me just keep the earlier syntax so that you can compare it. And I will just copy this and paste it here. And let's comment this. So what you can do is you can simply say, hey, every time there's a new name, just create a new object, but of student. And this is constructor reference. Looks good, provided you know the concept. Yeah, that's about the constructor reference, which is a kind of method reference because it's a type of method reference to be specific. Yeah, that's it from this video where we talked about the constructor reference. Or maybe we should have done this first. Okay, now that's where the video ends. So that's it from this video.